Hi guys, this is I'm Stuck, and in this video we'll be looking at chapter 3, which is Equations and Inequalities, and it'll be a brief overview of everything we've got. I'll leave timestamps down in the description below if you wanted to skip on to different sections, but let's get into the video. Now for this first question here, it says solve the following simultaneous equations, and we'll be looking at part A first. So what we want to do is we actually want to eliminate one of these unknowns, and how we're going to do that is we'll look at this first one first because it's a little bit easier. And we're going to take away this 3y here. So if we do that, we're left with x equals 11 minus 3y. Now, if we sub this x into this bottom equation here, we're left with 4. And instead of putting x, we'll actually put x, what x equals to. So that is 11 minus 3y. And then minus 7y. Equals 6. Now, if we expand that bit there, we get 44 minus 12y minus 7y equals 6. We add the y's onto the other side, so we get 44 equals 6 plus 19y. Take away the 6, so it's 38 equals 19y. And if we divide by 19, we're left with y equals 2. Now this y equals 2, that's half of our question already answered, but now we need to work out what x is. So if we sub this y equals 2, it can go into either one of these, but I'll put it into the top one because it's a little bit simpler. And we do x equals, x plus, 3, and instead of putting y, we'll do 2 equals 11. So then if we expand that bit out there, so we get x plus 6 equals 11. We'll take away the 6, so it's x equals 5. And that solved our question as x equals 5 and y equals 2. Now for the second question here, we're going to do the same step on the first bit, but as you notice, we have got quadratics on the bottom, but we'll get to that in a minute. So we're going to take away 2x from that top bit, so we're left with just y equals 1, take away 2x. And now we're going to sub this into that y down there. So we're left x squared plus, and then 1 minus 2x squared equals 1. Now if we expand that 1 minus 2x squared, that will give us 4x squared minus 4x plus 1. And then that will add the x squared to that. So add x squared, and that is going to equal 1. So if we simplify that out, that's going to give us 5x squared minus 4x. And we can get rid of these 1s because they're both going to cancel, and that's going to equal 0. Now to solve this for x, I'm going to get my calculator out. And if you've got the Casio ClassWorks one, go to menu and then set up the menu setup button and go to A, which is equation function, and then go to polynomial and select 2, and then we're going to put in 5 for that bit and then minus 4, and we'll keep that end bit as 0, and that will give us 2 values for x. So we get x being equal to 4/5 and also x being equal to 0. So then with that, we can then sub that into this top one here. So we get 2, and we'll use this 4/5 one first. So 2 4/5 or 0.8, either one, plus y equals 1. Now if we do that all together, so that's going to give us 8/5, which is 1.6. It's going to be 1.6 plus y equals 1. So if we take away that 1.6 from that side, we're going to be left with y equals negative 0.6. So that's going to be one of the values for y. But we can also do 2 bracket 0 plus y equals 1, which basically means that y can equal 1. So we have two options then. So the way we're going to write this is we're going to say when x equals 0.8, y equals minus 0.6, and when x equals 0, y equals 1. And that's our answer there, as we both have two answers for each x and y. Okay, so for this next part here, it says we can use the solutions of simultaneous equations to identify points of intersection with two or more graphs. So on the left here, we've got our two graphs. We've got 2x plus y equals 3, and then we've got y equals x squared minus 3x plus 1. Now, what we're going to want to do is we want to do the same thing here with the simultaneous equations, but we're going to actually find these equal these intersection points. So if we just look at the graph right now, so it says we've got this point here is going to be x equals 1, minus 1, and y is equal to 5. So that's one of the points there. And then the second point is this point here, which is x is equal to 2 and y is equal to minus 1. And that is the second point there. Now we're going to find this out and basically prove this by doing this bit here. So if we then say y equals 3 minus 2x, then we can say that x squared minus 3x plus 1 is equal to this 3 minus 2x. I'll just get rid of that bit there. Now what we're going to want to do is add this 2x to each side. So it's going to give us x squared minus x. And then we're going to take away this 3, which is going to say minus 2. And that's going to equal 0. Now, if we put this into our calculator, we find out that x is going to be equal to either 2 or minus 1. Now, if we then sub this x into this top equation there, because it's the easier one, we'll say 2 brackets 2 plus y equals 3, which will then give us 4 plus y equals 3, and then that means that y equals minus 1. Now, let's just prove this one's right there. So we've got this is for when x equals 2, y equals minus 1. Now, on this one here, this point of intersection, x equals 2 and y equals minus 1, which is correct. Now, if we do that with the same thing, but with the other value for x, which is minus 1, so if we sub that back into that top one there, we then get y equals 3, take away 2, that's going to be minus 1 there. So if we do minus 2, lots of minus 1, which is going to give us 2, so 3 plus 2 equals 5, so y equals 5. So for x equals 1, we get y equals 5, which is x equals minus 1, y equals 5, which is correct. So basically, that's just proven to us that we can use simultaneous equations to work out the intersection points of both of those ones there. So for this next set of questions, we'll be looking at inequalities. And this first one is find a set of values for x in which 8 brackets 1 minus x brackets is greater than x minus 1. So what we want to do is we're going to treat this greater than sign as an equal sign almost, Obviously, at the end of it, we're going to convert it back into the form they want it. But what we're going to do is we're basically going to say 8 that equals x minus 1. And we're going to expand this one here. So it says 8 minus 8x equals x minus 1. Now, if we add the 8x on and add this 1 on, we're left with 9 equals 9x. Now, if we remember what this sign was here, it was everything on this side is going to be greater than everything on this side. So we know that 9 is greater than 9x. So we can then say, if we divide it all by 9, 1 is greater than x. So x is less than 1. And that is our answer for that question there. Right, so for this next question, there is a quadratic in it, but for the most part, we treat it the same. So if we expand this top bit here, we get x squared minus 4x, and that's going to be greater than or equal to x squared plus 2. Now, if we want to take both of the x squareds away, because they both cancel, we're left with minus 4x is greater than or equal to 2. And if we divide both sides by 2 then, we're left with minus 2x is greater than or equal to 1. And then what we can do is we can flip the signs on both sides. So we're left with 2x is greater than or equal to minus 1. And then if we divide that by 2 again, we're left with x is greater than or equal to minus 0.5. And that is our answer for that one there. So for this next question here, it says use set notation to describe the set of values for which, and then we've got a, which is 3 brackets x minus 2 is greater than x plus x minus 4, and 4x plus 12 is greater than 2x plus 17. So we're going to do the same thing we've done before with the inequalities. So first of all, let's expand this top bit. So that gives us 3x minus 6 is greater than x minus 4. And if we take away x, so we get 2x minus 6 is greater than minus 4. And then we add this 6, so we get 2x is greater than 2, which means that x is greater than 1. So that's our first bit done. And then if we do the same on this side, so we get 2x, because we take away this 2x here, plus 12 is greater than 17. Take away the 12, which means that 2x is greater than 5, which means that x is greater than 2.5. Now, what we want to think about here, we almost want to put this on a number line here. So if we draw a little number line here, it's pretty rough. We'll just draw a little line there, and then we can add our values on here. So we've got 0 there, we've got 1 there, 2 there, 3 there, 4 there, so on. Right, so what we want to do here is we want to put our little circle. You may have done this at GCSE, but we know that this one here, so x is going to be greater than 1. So we do a little circle there, and we know that x is going to be all the way greater there. It's going to be all the way up there. It's always going to be that. And then we've also got x is greater than 2.5. So that's going to be at this point here. That's going to be all the way there, and it's going to go on until the end there. So basically, we know that the set of values is going to be x is greater than 2.5, because in the x is greater than 2.5, that x is greater than 1 is already included. So what we're going to write in our set notation is the way to do this. You do a little curly bracket. So you do a little one of those, and we say x, and then do a little colon, and then we say x is greater than 2.5, and then we close our curly bracket here. Not the best at drawing them, but basically that is what you want to do for that. So then for this next question, if we have an attempt at that, we've got both of these bits here. So if we simplify them out, so we get 5x, and then we're going to take away this 3, which means that is going to be less than 6, which we can then say x is less than 6/5. Or we've also got this bit here, which is going to be, if we expand this, we get 10x plus 5, and that's greater than 27. So if we take away the 5, we get 10x is greater than 22, which if we expand that again, simplify that again, we do x is greater than 2.2. So now we have these two different points. We've got x is less than 6/5, and x is greater than 2.2. So what we want to do is we want to imagine our number line again. So if we draw another little number line here, and we get our values down, so we're going to have to do a 0 there, 1 there, 2, 3, 4, 5, 6, 7, 8, so on. It will go on as well. So we get this x is less than 6/5. So 6/5 is going to be just above 1. So if we draw that one there, it's going to be boom. So x is less than 6/5, but then x is greater than 2.2, which is also going to be there. So that's going to go all the way to the end. So it's basically going to be two different inequalities because there's no overlap. In this one here, there was overlap, but we're going to have to do it in two different inequalities. So if we do our little curly bracket, we're going to do x colon, and then we're going to say x is less than 6/5. And then that's going to do another curly, not the best curly brackets. And then we're also going to do this sign, which is the and or sign. And it's that. And we're going to do the same thing, but for this one here. So it's going to be x colon x is greater than 2.2. Just get running out of room, but we're just going to do that there. So basically that there is our answer. So we get two different sections there because there's no overlap in them. So it's going to be that x is less than 6/5, but also x is greater than 2.2. And that's that question solved. So for this next question here, it's another set notation question, but this time it includes a quadratic. However, we deal with this in a similar way. And first of all, we want to look at this quadratic bit here. So we want to work out, if I do a little sketch for you, we want to work out where this quadratic curve, which is this bit here, is less than 0. So that is going to be this shaded bit here. We want to work out for where the curve dips below 0. Now, if we put it into our calculator, we get two values for x. We get x equals 2 and x equals 5. Now, this point here will be the x equals 2, and this point here will be the x equals 5. But we want it between these two values here. So if we say that 2 is less than x and x is less than 5, which would satisfy it being less than 0, that's our point there. So that's that inequality for this bit here. However, we also want to look at this point here, which is if we take away 5 from both sides, we get 3x is less than 12. And if we divide it by 3, we get x is less than 4. Now, if we draw it out onto our number line here, so if we draw out another number line, we'll plot our values upon that. So we'll start at 0 there. 1, 2, 3, 4, 5, 6, 7, 8. And we know that this point here, so if we look, we'll do this one first, which is going to be x is going to be between 2 and between 5, and it's going to be in this range here. And then we also know that x is less than 4, so it's going to be from that down to there. And we want to look at this intersection bit where they overlap here. Because there is an overlap here, we can put this back into set notation. So we can do the squiggly brackets, and we do x for values of x, and then we say x is going to be 2, which means this basically means for values of x, x is a greater than 2, but also less than 4. So as you can see, it's going to be greater than 2, but also it's less than 4. So that is our final answer there. Now for this next question here, it says, on a coordinate grid, shade the region that satisfies the inequalities, and it gives us this list of these 3 inequalities here. So first of all, we're actually going to want to draw these lines. So for this first one, which is y is greater than x minus 2, we know that it's going to have a y-intercept of minus 2, and it's going to have a gradient of 1. So if we draw that one there, so the y-intercept of minus 2 and the gradient of 1 will mean that as it goes across 1, it will go also up by 1. And that is minus 2 at this point here. So if we do a little dotted line, and it's a dotted line, not a solid line, because it is just greater than and not greater than or equal to. So that's our little dotted line there, and we'll label that one y is greater than x minus 2. Now if we look at this next one here, which is y is less than 4x, there's actually going to be the y-intercept in the origin, as there's no number on the end there, and it's going to have a gradient of 4, which means that it goes up across by 1, it's going to go up by 4. So it's going to look something like this. Oops. There we go. So then if we label that one, y is... Okay, so we've labeled that one there. As you can see, it goes across by 1, it's going up by 4 there. Right, so this next one here is then going to be y is less than or equal to 5 minus x. So it's got a negative gradient, this one here, and it's also got the y-intercept of 5. So it's going to cross through this 1, 2, 3, 4, 5. It's going to cross through that point there, and it's going to have a negative gradient of 1. So it will be the same as that, and we can then say this one's going to be a solid line, however, because it's it's less than or equal to. So we can draw it through there. That's crossing through point number 5, and it's also going down as a gradient of 1. And we can label this one y is less than or equal to 5 minus x. Now we've got all 3 of our lines drawn, and if we think about each line individually now, so we have to find out the region which satisfies all of these different inequalities. So it's going to, one is y is greater than this x minus 2. So it's going to be above this line here. And then one is y is less than 4x. So it's going to be below this line here. And then one is y is less than again. So it's going to be below this line. So we can find out then this this region, it's actually going to be this shaded bit in the middle because it satisfies all of the equalities. We can confirm that by then saying, oh, is this shaded region satisfying all of these? You look at each of the point, you say, is it less than, is it greater than? And as you can see, this point here is the shaded region. So basically, the summary of that question is you look at every single thing, you draw the lines, make sure if it's a greater than or a less than or equal to, you draw a solid line, and if it's not, then you draw a dotted line, and then that is your final answer. Now that's it for this video. So if you have any questions about anything, just drop a comment down below and I'll try and reply to that, and I'll see you in the next one.